Hello everyone, my name is Hamzin Naljas, and today I'm going to get an interview from the special guest Turarbek Janibek. And today me and Janibek are going to discuss about an industrial process of creating sulfuric acid. First of all, I think we need to talk about the author of this industrial process, whose name is Johann Glauber. Johann Glauber is a German-Dutch scientist that invented sulfuric acid in the 17th century by burning sulfur together with saltpeter, potassium nitrate, in the presence of steam. Product of this process, as you can understand, is sulfuric acid. Now, Janibek, answer me this question. Why is sulfuric acid so important?
Okay, Ojas. Sulfuric acid is an important product because it is used in many industries, such as manufacturing explosives, battery manufacturing, production of other acids, and also the production of the phosphate fertilizers. Also, sulfuric acid is considered the most produced chemical in the world except water.
Very interesting. Also, I read in New World Encyclopedia that in 2001, the world production of sulfuric acid was 160 billion tons, and the approximate value was $8 billion.
Okay, now let me present to you, Janibek, and our audience the global problem that is being solved by sulfuric acid. Sulfuric acid solves a global problem of non-recyclable, highly cost-effective, and non-rechargeable batteries that is on lithium. Lead battery is a battery that 37% consists of sulfuric acid, and this battery is one of the most used type of batteries because of these properties and characteristics like ability to get recycled, cheap in production, and ability to be recharged. Now let's talk about the most important part of this interview, and it is how sulfuric acid is made. I have no idea how this process is done, so Janibek, tell us about this.
Yeah, I would like to do so. So, sulfuric acid is used in a wide range of processes such as metal treatment, drug manufacture, paint manufacturing, and the production of explosives. Sulfur is considered the first raw material of the sulfuric acid manufacture, and it is transported by a tanker. It is obtained from local refineries from where it's being recovered from oil and gas. So it is transported as a liquid at around 140 degrees Celsius temperature, and the liquid sulfur is sampled before being stored for further acid production. Air is considered to be a second raw material, is drawn from the atmosphere where it is dried and compressed. The sulfur then is sprayed into a furnace where it burns into dry air. Sulfur combines with the oxygen in the air to form sulfur dioxide. S plus O2 equals to SO2, and the oxidation produces large amounts of heat. This heat is then needed to boil water, which produces steam, and steam itself is used to generate electricity. The gas mixture which leaves the furnace contains sulfur dioxide and enough oxygen for the next stage of the acid production. Next, in the converter, the sulfur dioxide reacts with more oxygen in order to produce sulfur trioxide, SO3. So 2SO2 plus O2 equals to 2SO3, which is considered a reversible reaction. So the reaction requires a catalyst, mainly a vanadium 5 oxide, which is most effective at around 440 degrees Celsius temperature, at which the main chemical reaction occurs. There, in the converter, it combines with oxygen in order to form a V2O5 catalyst. And so there are 4 beds of catalyst in the converter. The first catalyst bed converts about 63% of the sulfur dioxide to sulfur trioxide, and heat is produced, meaning that it's an isothermic reaction. Then the gas stream is cooled before it passes to the next catalyst bed. Hot gas superheats steam from the furnace boiler, and the gas stream passes through the 2 further catalyst beds, and the percentage conversion increases. Between each consecutive stage, hot gases are required to be cooled. And by the third stage, around 95% of the original sulfur dioxide are being converted to sulfur trioxide. After the third catalyst bed, the gas stream is led into the bottom of an absorption tower packed with ceramic material. The rising gas meets a stream of hot sulfuric acid that runs down the absorber. The sulfur trioxide reacts with the water in the acid to increase the concentration of the acid to about 99%, so that SO3 plus H2O equals to sulfuric acid H2SO4. So the gas from the top of the tower still contains some sulfur dioxide and oxygen. Therefore, it is fed back to the third catalyst bed of the converter, after which around 99.5% of the original sulfur dioxide are being changed to sulfur trioxide, further forming oleum, H2S2O7. When the sulfur trioxide subsequently dissolves in concentrated sulfuric acid. The 99% of concentrated sulfuric acid H2S2O7 is diluted with water to increase to about 99%, and this increases, therefore, it increases the volume of the acid. This after 1% or so is the volume of the acid that has been made. The acid concentration is, of course, checked by sampling. And besides sulfuric acid, the plant generates a large amount of heat, which is used to boil water, as I said. And this boiled water produces steam to make electricity. And this electricity is then sold to the national grid.
Wow, this is amazing information. I never understood how this process works, but now you opened my eyes to this topic.
Okay, Zhenibek, as you already talked about the process of creating sulfuric acid, now let's talk about the advantages and disadvantages of creating sulfuric acid from, let's say, economical and environmental factor. Okay, let me start from the advantage.
Sulfuric acid is the second most created chemical besides water, and because of this it generates 8 billion of US dollars to the world economy, which is a beneficial for the economy of any country in the world.
Also, sulfuric acid is produced from sulfuric dioxide, a significant air pollutant which lowers overall emissions. Because of industrial process abundance and versatility, sulfuric acid is used in a wide range of sectors, including batteries, metal processing, fertilizer, and pharmaceuticals, which generates billions of dollars in different spheres of economy. So I stated all the advantages, and now let's talk about the disadvantages. The cooling and absorption phase of the creation of sulfuric acid requires a big amount of water, which could ruin the storage of water on local water supplies. Also, I think due to the extreme corrosiveness and toxicity of sulfuric acid, the soil and water that contacts with sulfuric acid pollutes the soil and water. The creation of sulfuric acid produces pollutants like carbonic mist and nitrogen oxide, which contribute to acid rain that harmfully affect the environment. Because of high temperature and pressure that is required in this process, a large amount of energy is used. Because of this, the greenhouse gases occur that negatively affects the air and climate change. So in order to conclude all of our interview, let's answer 3 basic questions.
Zhenibek, what is the probable future of this industrial process?
The future of sulfuric acid manufacturing seems to be quite promising and expects rapid growth by 2029. According to Modern Intelligence, the market size of sulfuric acid production is is estimated to be at 321.05 million tons in 2024 and expected to reach 384.25 million tons in 2029, growing at the CAGR, compound annual growth rate, of 3.82% during the forecast period. The high demand for sulfuric acid in phosphate-based fertilizers and the growing demand from the chemical and pharmaceutical industries around the world.
Are new methods and catalysts being tested?
According to Thomasnet, February 5, 2024, new methods and catalysts are indeed being tested. For instance, DuPont cloning technologies introduced 2 new sulfuric acid catalysts, Max Super Gear and Max XLP 110, which build upon its well-proven Gear and XLP catalyst product lines. These catalysts aim to help acid plant operators increase conversion and improve environmental performance with minimal investment. Other developments include the use of ion exchange resin, supported hydropolyacids, zeolite, silica, enzymes, and metal oxide catalyst, according to Felicia et al. 2021, December 17.
What is the likely effect of the economy and environment? And Zhenibek, let me answer this question as we already discussed previously. The environmental effect of creation of sulfuric acid is negative because of toxicness and corrosiveness of sulfuric acid that can damage water and soil. However, the creation of sulfuric acid is beneficial for the economy because it provides many job opportunities to society and it generates around 8 billion US dollars every year.